Welcome to lecture number 7 in the course EEE 6211. And today we'll be looking at the OSI and TCP IP model. The presentation outline will run as follows. I'll give a brief introduction about the two models, and we'll look at each of these models in a bit of some detail. And I'll basically talk about the two terms, encapsulation, decapsulation, before I also give you a tutorial. Now, the TCP IP models formulates the communication process into some kind of structured layers. It's an abstract description for network protocol design. It was developed as an effort to standardize networking. The models act as a frame of reference in the design of communications as well as networking products. And I must emphasize, being an abstract description, basically we mean that you will not see a physical layer. The layers themselves, they are basically in abstract format. So it's an abstract description of the whole networking protocol design. So moving on, let's talk about the OSI model. The OSI are basically standing for Open Systems Interconnection. This is a model which was introduced in 1978 and later revised in 1984. It has 7 layers, starting with the physical layer at the bottom, the data link network, the transport layer, session, presentation, and at the top, or layer 7, we have the application layer. So let's now look at each of these layers as well in terms of functions and the major activities that happens at every layer. So let's begin with the application layer. The application layer interacts with application programs, and it is the highest level of OSI model. It provides services to different user applications, and these applications or services range from email services, they range from remote login, web, file transfer, and so on. So let's now look at the functions of the application layer. Mail services, the application layer under this service provides various email services. We also have the file transfer and access service, which allows users to access files in a remote host to retrieve, as well as to retrieve files from a remote computer for use. And related to this function is remote login, whereby a user can log into a remote computer, work on a file. In fact, you log in using username and a password, work on that file, and after that, close the remote file or remote computer. It differs slightly from the file transfer in the sense that with file transfer, you can send the information to a remote computer and also retrieve information from a remote computer, and then you work on it. But whereas in remote login, you basically log into a remote computer, work on the information on that computer, save and close the remote computer as though you are actually working at that remote place. The other service has to do with the World Wide Web. This is where the application layer basically provides web pages. This allows you to access information from a remote server kilometers or even thousands of kilometers away, but you don't necessarily need to log in by way of a user ID or username. Next is the presentation layer. The presentation layer, which is layer 6 of the OSI model, defines the format in which the data has to be exchanged between the two communicating devices. It handles such things as data compression, encoding, and data encryption. And talking about data compression, encoding, and encryption, in data encoding or basically presentation, here the presentation layer ensures that the data being sent is in the format that the recipient can process. well as in data encryption. The presentation layer ensures that the data is encrypted. Information intended for one device, does not end up going to the wrong device. It basically hides the information from everyone else except the person who originally sent the information and for whom and to the intended recipient. In data compression, this is where a large amount of data is reduced to smaller pieces or reduced in terms of size. This is very important, if you transmit or store information over a limited bandwidth and also over a limited storage facility. Next, we have the session layer. The session layer defines how to start, control, and end the conversation between the two devices. It does so by giving session IDs, whereby the two users will need to log in using some password for validation. It also provides dialogue displaying, determining whether the communication will be full duplex or half duplex or simplex. And besides that, it has also to do synchronizing, synchronization between sender and receiver. All these are done at the session layer. After the session layer of the transport layer, the transport layer does data segmentation, whereby the payload data is broken into various segments, and each of those segments are given some heading, some header files. And the basic function of this layer is to ensure that data units are delivered error-free, and also to ensure that the segmented data is put in sequences even as it moves from the transport layer to the next layer, which is the network layer. The other transport layer functions basically to ensure that there is no loss or duplication of data units. It also provides connectionless or connection-oriented service, determining whether it's going to adopt user datagram protocol or transport control protocol at the transport layer. Next, after the transport layer, you've got the network layer. The network layer implements routing of packets through the network. It defines the most optimum path to be taken by data. It also defines logical addressing and handles network congestion issues, and ensuring that interconnection between heterogeneous networks, these are networks, different networks, are properly handled. It has to define how fragments of a packet, how to fragment a packet into smaller packets as well. Next, we have the data link layer, which breaks outgoing data into frames and then reassembles these into frames. It also creates and detects frame boundaries. At the same time, it will handle errors by implementing what is known as acknowledgement and the transmission scheme. And this is done by way of using the cyclic redundancy check. It is also a functional data link layer to ensure that these frames are converted into ones and zeros as they move in the physical layer. So in the physical layer, basically, you have a scenario where bits are being transformed into electrical signals. The ones and zeros being converted into electrical signals, and it also provides synchronization of these bits by way of a clock. The physical layer, in addition, also manages the way a device connects to network media. Is it going to be via radio? Is it via cable? And so on. It defines the transmission rate. The data rate are basically determined at the physical layer. Other physical layer functions is basically to provide physical interface for transmission. It also covers all mechanical, electrical aspects for physical communication, defines voltage levels, timing of voltage changes, determining the maximum transmission distances, physical connectors, and so on. It also provides the physical topologies that are to be adopted, whether it's going to be star topology, mesh topology, tree topology, bus topology, ring topology, and it can also use different different techniques for multiplexing of information. Is the information going to be, is it going to be time division multiplexing, frequency division multiplexing, and so on and so forth. Next, let's talk about the TCP/IP model. The Transmission Control Protocol Internet Protocol suite was created by the USA Department of Defense. The basic idea there is to ensure that communication should survive conditions and ensure that data integrity is not compromised even under serious malicious attack. This model has 4 layers. You have the application layer at the bottom, then you have the host-to-host or transport layer, the internet layer or network layer, network access layer, combining. Now, if you look at this model, it's quite similar to the OSI model, in the sense that with the TCP/IP model, the application layer covers what was covered in the application presentation and session layer under OSI model, and the host-to-host is equivalent to transport layer, the internet is equivalent to the network layer. The network access combines the function with data link as well as the physical layer. This is just another diagram to illustrate that in some books, instead of calling the host-to-host, it will still be called transport layer. And instead of calling the internet layer, it will be called network layer. And the network access sometimes is called network interface layer. In terms of function, the application layer deals with the data presentation, encoding, compression, as well as handling of dialogue control issues. All these issues are combined together under the TCP/IP model into a single layer, whereas as we saw in the OSI model, 3 distinct layers were used to define each of these components. Next, we've got the host-to-host layer, which is equivalent to transport layer in the OSI model. Its responsibility include application data segmentation. So it will do data segmentation, breaking into various segments, fixing some header information, determining the appropriate routing protocol, transport layer protocol, and also handling transmission liability, flow, and error control. Then we've got the internet layer, which is equivalent to a network layer in the OSI model, and its purpose is basically to route packets, from the source to correct destination, and also to avoid the congestion issues, data packet drops, as we saw in the network layer in the OSI model. Then network access layer, this one deals with physical issues concerning data termination of network media. It combines the function with data link as well as physical layer, which were discussed under the OSI model. Basically here we have information being converted from frames to 1s and 0s, and from 1s and 0s into signals consisting of voltages and currents, and these are now put on the physical media ready for transmission. Next, I want us to talk about data encapsulation and decapsulation. In data encapsulation, this is a scenario whereby as message begins to move from the application layer to the physical layer at the bottom, the message will undergo several changes by way of adding header information. So as the message descends, each successive OSI model layer adds a header to it. And this header will basically explain what was done at every layer. So a header is a layer-specific information that basically explains what function the layer carried out. Conversely, at the receiving end, headers are stripped from the message as it travels up the corresponding layers. So what is being basically referred as encapsulation is the process of adding headers to the data as it moves from the application layer to the physical layer. Whereas data decapsulation is the process of removing these header files until, as the information moves from the physical layer to the application layer. So at every stage, headers will be removed until at the presentation layer, you retain the original information before it was sent, out of the source device. So that is data encapsulation as well as data decapsulation. So the basic thing to remember really about these two terms: with encapsulation, you're adding header files or headers to the data, while with decapsulation is the process of removing data as it moves from the physical layer to the presentation layer. Then I have also a few tutorials, a few more questions. So this marks the end of our lecture for today. Thank you for listening.